This content area is called weather, and it's all about the weather patterns that we see in our everyday lives and the scientists who are studying them to keep us safe. So our first exhibit in the weather content area is going to be the exhibit closest to the Trailblazer entrance door. That way in all of the content areas, the kiddos move around in an organized fashion. So we have our big tornado right here, which is really awesome, and we also have tornado tubes. Now this is going to make a little bit of noise, but I'm going to turn it on and we're going to watch how the tornado forms. So tornadoes in real life are a combination of a cool air that's pressing down and warm air that's pressing up, and it's creating unstable air in between. So the rising warm air creates an updraft and an upward pull that is strong enough to lift trees, animals, and buildings. If you've ever seen any actual video footage of a tornado, you know exactly what I'm talking about. So you can see inside we have those two different weather systems and we're creating a funnel in there. But we also want to create one on our own. So we have this awesome tornado tube, and the motion that you're going to use is kind of like you're stirring a big pot of soup, but you're going to turn it upside down and do it really quickly. So I have the kids put their hands with their thumb down just like that, and then on the count of 3 we're going to turn it and we're going to watch the vortex form inside. Stir that pot. And inside you can see a tiny tornado just like our big tornado. Now, somebody who actually studies tornadoes in real life is called an atmospheric scientist. They're making about $90,000 a year. So our next exhibit in weather is called our radiometer. So it's actually this little device here. And what it is, we have panels that have a black side and a white side. So we're gonna turn on this lamp. And what's happening is the blackened surfaces are absorbing light particles from the lamp and getting hot. The heated gas molecules are starting to move to the cool side, and it's creating movement inside. So as the molecules move to the edges of the fan blades, they create a pushing effect, and it makes the blades spin. So material scientists actually use concepts like we see here to make new thin film cells to make solar technology even more efficient. And those material scientists can make about $101,000 a year. This exhibit here is our plasma ball. So we're going to look inside and we're going to see something that looks like lightning. Now this isn't exactly how lightning works, but we are going to talk about a concept that lightning uses. So inside we have positive charges in my hand and negative charges inside the glass dome, and they're going to connect and we're going to see those electrons move. Now lightning actually uses the path of least resistance in the same way that these electrons are. So electrons like to go through conductors, which are things that electrons can flow through, like water or metal, those things that we make wires out of. Now lightning, when it strikes, it's going to find really tall structures like trees and buildings, and it's going to strike those first because it's less resistance to go through a conductor than it is just to go through the air. So the electricity moving through our body, because we have water in our body, we can see through here. Now if you have two people come up, if somebody is more hydrated, they're more likely to see the brighter blue line go to them than their friend who's a little less hydrated. So a STEM job that's thinking a lot about this type of electricity is an electrical engineer, and they make about $95,000. So this exhibit is called Forecast the Weather. So we want to see what it feels like to be a meteorologist in front of the green screen and actually tell the weather to people. So we're going to have all of the setup here, and the kids are actually going to walk back here with me to this big bright green wall. So when I'm back here, I actually see green painted behind me, but on the camera on the screen in front of me, I see a map. So just like a meteorologist has to tell us the weather and move kind of with what they see on the computer screen and not what they see on the background behind them, we get to practice that same thing. Now, meteorologists are really important parts of weather predicting. We all get our weather news from them. But another STEM job that we have to think about is who makes this green screen technology possible. So visual effects editors make $75,000 a year making cool stuff like this. Now let me show you my favorite part. I have green behind me, but what happens when I put green in front of me? I disappear!